Hey everybody, this is Larry. This is day 10th of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's poem. Let me now look at this. What is this early access? That's fine. Today's poem is 1359. Count all valid pickups and delivery options. Given n orders, each order consists in pickup and delivery options or services. There's a mod thing, so let's do the mod real quick before we forget. Hope everyone's having a great weekend. It is Saturday night here. Kind of hurt myself a little bit into a little bit of a, I wouldn't say car accident, but I guess it's not a car accident. It's an automobile accident or whatever. Well, that's not the same. That's the same. I'm in a motorcycle accident, so someone almost ran me over on the street. So kind of hurt my leg a little, hurt my hamstring, kind of trying to get out of the way. So, but all right, let's see. So basically, you have 2 times n items where you have P1, D1. Okay, in some interleaving order. N is 500. I mean, intuition would suggest that this is combinatorics and probably dynamic programming in some way. How do we actually structure it so that we actually get the answer, right? 2. I mean, I think there are a number of ways you can structure this. Given the n is equal to 500, we can kind of just structure it recursively. But I'm trying to think about there are a couple of ways you can do this cleanly. So I'm just trying to think about the way to do that, right? Yeah, I mean, I think the easiest, at least I don't know. I think easiest is maybe relative, but the way that I'm thinking of right now is that you just kind of keep a counter of what you can do. Right? What's the next thing? Oh wait, no. Okay, maybe I misunderstood this problem a little bit. Hang on. I thought that. Okay, so I actually misunderstood this. I thought that P1 has to go before P2. Like the pickup has to be in order. Like 1 has to go before 2 or something like this. But I guess it doesn't matter as long as P sub I is less than, or it's before D sub I. Okay, so I misunderstood this, because in that case that would be dynamic programming. You just kind of go one at a time. I mean, it probably still is dynamic programming, but we have to think about it a little bit more. Well, I have to anyway. Maybe you already got it at home. Let's kind of visualize this a little bit, right? So let's do this. I wouldn't say recursively, but iteratively, right? What does it look like? So we have P1, D1 to kind of start off, and this has to be in this order just because. I mean, that's just the constraint, right? And then now you have P2. Now you're trying to insert P2, D2, right? And how many ways are there to do it? Well, one way for this is to both be. Yeah, so then now you can maybe kind of think about them as dividers, and then now you can think about it as one here, one here. I mean, there are a lot of ways to do it. I guess 6 ways is how they structure it, but you can kind of think about it as in terms of this, and then maybe P1 and in that way, because we already set up P1, D1, we can even actually just think about them as dividers. Maybe some of you will know what I'm getting at now. And then you kind of think about brute force these things, right? And then do P2, D2, and then finally, right? So something like this, right? And then now you get a number. In this case, it's 6, right? So you have f of 1 is equal to 1, f of 2 is equal to 6, right? And what does this mean? That means that now there's 6 ways to have 4 dividers, right? Because we calculated, we got, now there are 4 dividers, and there's 6 ways, and now we're trying to do D3 or P3, D3 into 4 different dividers, and the and the 4 different dividers have 6 ways of counting. So you would times, do some multiplication things, right? And how many ways are there to structure this? To put in the 3. Well, in a way, so let's go back for a second, right? Going from F1 to F2. Now we're thinking about it in terms of 2 dividers, and we're putting 2 things in there, right? In a way, is that true? I'm trying to think really quickly. Sorry. So in this case, there's 6 ways to do it, because you can kind of think about it as if the first, so if the pickup is in the first one, then there are 3 ways to do it, right? If the pickup 2, sorry, is in the first slot, there are 3 ways to do it. If it is in the second slot, there are 2 ways to do it, because it has to be after 1. And then if it's the last slot, there's 1 way to do it. So then you have 3 times plus 2 plus 1 times 1 way to kind of make the dividers. So that's why there's a 6, right? And then in kind of that sort of visualization, you have, for this is equal to 3. You kind of have the same way. So then you have 4 dividers. That means that there are 5 ways to, if you put P3 in the first slot, there are 5 ways to choose the D3. And then if you put it in the second slot, you have 4 ways, 3 ways, 2 ways, 1 way. And then you have to times this by 6, because there's 6 ways to kind of order the dividers, right? So in this case, what is this? It should be 90, so that's what we will be checking. But of course, you should still do the math. And of course, this is just 15 times 6, which is 90, right? And I think that's it, right? I think that's the pattern. Because then now, you try to put in P4, D4, and now you have 6 thingies, right? And then now, and as we get, we have 7 plus 6 plus 5. And of course, there's a formula for this one, which is 7 times 6 over 2, right? Is it 7 times 6 over 2? So it's 21, is that right? Or is that 7 times 8 over 2? Maybe. Okay, let's try with a smaller number. So this is 6, so this is 3 times 4 over 2. Okay, yeah, so this is 7 times 4, which is 28, times, I guess, 90. So 28 times 90 is equal to, this part I'll use a calculator. Right? And then now, of course, you can't do this during an actual contest, but for our sake, I'm confident anyway, but we can run it real quick. To kind of cheat by getting, seeing if that's the answer, right? Yeah. Oh, wait. Yeah, so this number matches, so we're good. I think that's good. If I sound too happy and I'm sounding too proud or whatever, it's because I did come up with this like right now in the scratch with this visualization. I don't remember how I did it last time. I must have done, I don't know, but it's kind of always cool to kind of just come up with something like on the spot, right? Especially since, I don't know, I think like 2 days ago I talked about having seen all these problems before, and it's kind of getting a little bit stale, a little bit boring. And even though I have seen this one before, it is still kind of cool to kind of come up with the visualization and see the pattern and just code it. That said, I have to actually do it first, so let's do that, right? So, okay, so let's say we have a loop. Put my fingers in the right slot first. Let's start with 1 and then plus 1, just because it's easier to visualize, right? Or maybe even start with 2. Because then now we can say, yeah, dividers is equal to 0, count is equal to 1, right? Which is this. And yeah. And then for each one, I guess dividers is just equal to, I guess we could just add 2 or something like this, but it's actually equal to I times 2 or I minus 1 over times 2, right? Because basically we're doing I minus 1 is the number, is the previous thing that we're looking for, and then half of the, and then we have 2 dividers, one for the pickup and one for the delivery, and that's the number of dividers, right? And then now we have to put in the pickup and the divider. So yeah, so what is that? So you have dividers plus 1, number of choices. All right, let me just write it out as variables. So now we have choices for pickup. We have yours dividers plus 1, and then as we said, you just sum it over the thing. So then it's gonna be okay. Maybe I'm just gonna show under the choices. Otherwise, it's gonna be a long thing. So otherwise, we have choices times choices plus 1 over 2, right? And that's just the summation formula from 1 to 1 plus 2 plus 3 dot 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 all the way to choices, right? So that's the number, and then we want to times this by the count, which is the previous thing, and that's pretty much it, right? And that's going to be the count, the new count for the next count. So after that, I think we have to be a little bit careful, of course, with respect to mod. This will work. I mean, we have to do a intermediate mod, but I just wanted to check real quick. And then here we can mod it by mod. I think we should be good. Dividers will be at most, what is it, like less than 1,000? Like just a little bit less than 1,000, so this would be under 1,000,000. If this is mod, is under mod, it should be fine. Yeah. Let's actually also run it real quick for a big case. I've been very sloppy lately, so maybe this is a good pattern for... yeah. Cool. And we can actually do another additional optimization. Which is noticing that there's only 500 possible answers, so you just have an array of 500 elements. I'm not going to do that because that's just silly, but... apparently I did do it that way last time, so that's kind of cool. Yeah, and I... okay. Yeah, this is linear time. Oh man, I made the mistake that I always say don't do. This is O of n time, and O of 1 space. This is... it's not... oh man, I maybe I hit my head a little bit. No, this is not linear time because n is not the number... or sorry, the input... because when people say linear time, it is linear in the size of the input. And the size of the input is not n. N is a number that is represented by the number of bits, or n is being represented by log n number of bits, which is the size of the input, right? Because if this n is say 1,000, so I think it cannot be 1,000, then it takes 10 bits to do it. To you know, and the size of the input is 10 bits, not 1,000, right? 1,000 is the input, 10 bits is the size of the input, and in this case, this is exponential and linear space, if you want to phrase it in that way. But otherwise, this is O of n time and O of, I guess, 1 space. Anyway, that's all I have for this one. I guess I did the same thing last time, but I don't remember it. How long was it? It's only a year ago. I thought it was a cool problem. I don't know. I feel happy for solving it. Let me know what you think. Let me know how you did. Let me know how long you took. Yeah, that's all I have for this one. Stay good. Stay healthy to good mental health. If you're doing a contest later, good luck. I'll see y'all later and take care. Bye-bye.